Greetings Tryon and peers who are viewing but also peer marking our assessment task. This is Francis Lorente representing Kristian Vulcik for our air resistance experiment. So when approaching any experiment, we have our three types of variables. Our controlled variables that we're keeping the same, is the mass of the army men, as well as the amount of drops we have for each parachute. Three types of parachutes, or sizes 3 drops, so 9 drops in total, just to make it a fair test as well. Our independent variable that we are changing to see whether there are results or an effect to our hypothesis is the size of the parachute. So we have 10 by 10 centimeters, 15 by 15, as well as a 25 by 25 centimeter. Our dependent variable, which we aim to measure, is the duration of the drop affected by the parachute, in which catches the amount of air particles depending on its size. So our hypothesis is to get a linear result. So the smaller the parachute, the less time for the parachute to activate but also catch air particles, and there's less space as well. But as the parachute gets bigger to the 15 and then biggest to the 25 by 25 centimeter, bigger I should still say, then more air particles are caught. Therefore, the slower the drop because of the level of air resistance that is acting upon the parachute. So, our risk assessment, of course, just for this is we're using a step ladder as we are dropping from a 2.5 meter gutter. That is also our controlled variable. We are dropping it only at 2.5. Please know how to use a step ladder. Please make sure that it is of course set up correctly and maintain a steady balance. Please have someone to hold you if you can. Do not fall. All the best. Yep.
So we're going to start with our small one. Set, go.
That's 1.6.
1.6.
Alright.
Ready, set, go.
1.57.
So that's pretty close to the first one.
That's it.
Do a breeze and
Just waiting it out. Yep.
Okay, ready, set, go.
1.65.
Not bad, not bad. You ready? Ready,
Yep.
set, go.
That's 2.02.
2.02. Whoop. Okay,
Alright.
3, 2, 1, go.
2.36.
Okay, that's a parachute I would want to jump with.
Yeah,
that
that's
landed nicely.
that was clean.
Third run. Third and final. Ready, set, go.
2.09.
That was that I really liked how
That was clean.
that one was clean. So size comparison, this is the 25 by 25 versus a 15 by 15. Already just by looking at it, the larger the parachute gets, the longer it's taking for the parachute to hit the ground. Obviously more air particles are catching underneath. So in theory, in line with our hypothesis, this one should take longer than what the others have so far. Should catch more air particles.
That's it.
Again,
Yep.
Ready, set, go.
That was 3.54.
3.54. Would we have caught that in the whole video? Maybe
No,
not.
it skimmed out.
Yeah.
But I pressed it the moment it hit the ground.
Yeah, beautiful. Right, take 2, 3, 2, 1, go.
3.15.
3.15.
Interesting.
Interesting.
Could you say like variables could include like a breeze?
Yeah, a breeze definitely, like what we just experienced there.
Here we go.
Is that in frame?
That's in front.
Yeah, ready. 3, 2, 1, go.
2.95.
That was nice.
Kristian and I then decided to use ICT by putting our results in a Google spreadsheet to represent what we found in the experiment as a line graph. Referring to our hypothesis, we believe that we're correct in saying that the bigger the parachute is, the longer it took for the army men to reach the ground, as opposed to the smallest parachute, having collected less air particles, shows that air resistance had acted upon it less. Therefore, we would want in real-world thinking the middle-sized parachute, which is red on the graph, because it is appropriately sized. The bigger it is, I should say, the longer we are in the air, but we don't know where we would end up. The smaller the parachute would most likely end in our demise. To conclude our video, we decided to use Scratch as our digital technology. What I found really interesting about Scratch is that it is an online coding website that relies on block code. What was really cool about it was I was able to input the exact seconds that each parachute fell at. And I was also able to put them all, each parachute, on the test 1, test 2, and test 3 in the exact same video and play it out so that they can be compared and contrasted visually. What I struggled with was switching between the scenes. So what I needed to do was, the moment I press the green flag, which starts the animation, that shows trial 1. When I press the space bar, it skips to the next image, which just changes trial 1 to trial 2. And then once again, when I press the up key, it changes the image to trial 3, and it shows the third test run, comparing each of the parachutes at the same time. What I did was also change the character sprite. The yellow ball is representative of the smallest parachute with the yellow army men attached to it. And then when you work your way to the right, the green ball is associated with the green army men attached to the largest parachute, which is 25 by 25 centimeters. So, trial 1, you can tell visually that, of course, the bigger the parachute is, which answers our hypothesis, the more air particles that it collects, the more that air resistance is activated and it stays in the air longer, as opposed to the small parachute collecting less air particles, which, as I said earlier, means a shorter fall. Thank you for watching our video, and we hope you learned something new about air resistance as well as parachutes.